Well, first of all, I want to thank everybody for being here. This is a big block of time that many of you have taken out of your lives to come and participate in this, and I am really thankful that you're here, and in particular, I want to extend my thank you to those who've come from far away to present information on some of the systems that you work on and to help us have a dialogue and inform us about some of the things that we do here in the Bay Delta. So last night after the reception, I was mulling over exactly what I would talk to you about today. The ARC stays open until 1 o'clock in the morning, so I had plenty of time to sit here and think and put together a talk. Ultimately, when I first thought about presenting to you, I was thinking about giving a bit of an overview that basically had a simple take-home message, and that simple take-home message was we heard a lot about complex systems and science strategies and science programs here in North America, but there are also some very, very good examples internationally. And so initially I was thinking about giving you an overview of a few of the ones that I have some familiarity with. I kind of decided to opt out of doing a multi-site presentation. I'm going to focus on one that I know best. But before I launch into that, I thought I'd at least give you a little bit of background information. I don't know how many of you know about the International River Foundation and their annual River Prize. This is a prize given, substantive prize, 300,000 Australian dollars. It's given annually, and it's been given since 1999 for outstanding management of river basins worldwide. And the awards have really, in many cases, identified some excellent programs where I think you could look for successful science strategies. Some of the ones that I've listed here on the slide that you see is the Lake Eyre Basin in outback Australia. It was got the award 2015. The River Rhine, particularly focusing on the lower Rhine, in 2014. The River Thames in 2010, and its recovery from some very serious degradation was the winner then. Danube River, particularly in the area around Vienna, was the winner in 2007. Sha River in China was the winner in 2006. Mekong River in 2002. These are international examples of where smart people have developed interesting and important programs and are doing really good things. One of the other winners from North America that I thought I might just throw up here on the list is the Willamette River, which won in 2012. And one of the things that I've always admired about the Willamette River program is their wonderful planning atlas that they completed in 2002, which has been a guide to the kinds of restoration and basin level management that they've done. And if you haven't seen that planning atlas for the Willamette River, it's well worth looking at. Reminds me very much of some of the things that the San Francisco Estuarine Institute is doing with their historical ecology and then bringing that up to how we might use that kind of information in management issues here in the Bay Delta. So the other area that I had some experience with when I was actually here earlier as the lead scientist from 2008 to early in 2012. So I got invited to actually go and give a plenary talk in Japan. The Japanese have a society that's called the Ecology and Civil Engineering Society of Japan. They have an annual meeting, 1,000 or so people come, so it's a fairly big deal. And it was impressive to me how much river restoration, basin restoration, coastal management goes on in Japan. I bet it's comparable dollar-wise to what we do here in the United States. One of the reasons why it's comparable dollar-wise is that these are very built environments, and that's why they have this society where they link civil engineers with people who are doing ecological research and doing restoration, because it is a very difficult thing to do within these built systems, and it's expensive. Yet they've committed a lot of resources to do this for things like their anadromous fish populations, for example, or some of their freshwater aquatic mussels, for example. So really interesting examples from that part of the world. But what I'm going to focus on and just show you a few slides about is the Healthy Waterways Partnership in southeast Queensland. And the Healthy Waterways Partnership is something that I went to learn about on my sabbatical in 2007. So in 2007, I was doing quite a bit of work on the Willamette River Basin I'm not the Willamette River Basin, sorry, the Rio Grande River Basin in New Mexico. I had gotten very interested in some of the issues of science monitoring, science decision making, and I had heard a number of presentations at international and national meetings about this healthy waterway partnership that was going on in southeast Queensland. And I was very impressed with some of the things that were presented. Maybe they're just good salespeople, but the talks I had heard really impressed me with what they were doing, and I said, okay, this would be a great place to do my sabbatical. And in addition, my interest at that time was moving more and more towards the study of intermittent rivers. Intermittent rivers make up half of the river network, probably approximately worldwide. They're understudied systems, and the Australians, particularly in outback Australia, had really focused on studying these intermittent systems. I wanted to have the opportunity to kind of combine those two efforts. All right, if I get this to work. Down is right? I'm sorry. I'm making it. It's not changing on the screen here, but it's changing up there. So, all right. I will view there, and I will make this work. We all seem to be challenged with this clicker. Okay. So here's the Healthy Waterways Partnership, and again, I want to thank Stuart Bunn, Australian Rivers Institute Director, for these slides. He actually gave this presentation 2014 and loaned me these slides, and I have borrowed heavily from them. One of the things that I really liked about the Healthy Waterways Partnership was not only the monitoring program and the science program that they had developed, but also the communication program that they had developed. So this is the part of Australia I'll be talking about. This is southeast Queensland. The area that is under study is 15 major catchments, about 23,000 square kilometers. It includes a lot of different jurisdictions. These jurisdictions actually contribute to a fund that actually pays for the research and monitoring that I'm talking about. It's an area of about 2.5 million people. It's the fastest growing part of Australia. And one of the iconic parts of this area of southeast Queensland is Moreton Bay. It's a focus area of recreation and an area that a lot of both local and tourists visit. There were growing problems within the bay. The problems are some of the kind of problems we heard about yesterday. They had problems with sediment and with increasing turbidity within the system, and they had problems with nutrients and eutrophication. They also had problems with the loss of some of their beneficial seagrasses that were in the estuary. So these were the drivers that basically caused them then to start this program. The program was initiated in the late 1990s, and the kinds of things that got the people engaged were some of the iconic species that spent a lot of their time in the Moreton Bay ecosystem, and the sports fishery that was pretty much associated with Moreton Bay. So a dugong there, a sea turtle, and a sport fishery. One of the things that they initially then did was to develop a monitoring program for all of these catchments to identify where the sources of sediment derived from within the catchments. One of the interesting things that they did early on, and something we heard very much about yesterday, was the importance of models and modeling to help them understand the dynamics of the sediments within these catchments. It became quite clear that the vast majority of the sediments were coming from a fairly small part of the landscape, so 30% of the landscape was contributing more than 70% of the sediments. And then a second level question that was then asked that actually then generated some directed research was how much of the sediment that is getting into this bay is coming from sediment that is basically associated with active river channels versus how much of it was associated with row crop agriculture versus how much of it was associated with incision and arroyo formation. What were the sources of sediment? And so the work that was done actually pinpointed that a vast majority of the sediment, which was coming from a subset of the overall catchment, was derived from sediment that was really in that active channel. And in many cases, these are active channels that were incised and active channels where there was a lot of bank spalling and erosion. So that was one of the aspects of the early work to characterize sources of sediment. The monitoring program that was set up then allowed them to get an idea of the amount of material coming in from various catchments. Much of the movement of this material was very much event-driven. So basically, dissipating tropical storms, for example, major source of sediment, as it is, for example, in Chesapeake Bay. And this kind of information then directed the focus of their restoration efforts to a number of these most heavily degraded stream systems. They initially started with some pilot experiments in some areas that they knew were problematic. And so here's an example, one from Echidna Creek. And here was the condition you see with the incised channel, limited riparian vegetation in 2001. Combination of replanting, getting the grazing animals out of the system, and some recontouring. 2008, here's what that catchment looks like. So they had some success in getting revegetation back in some of these highly eroded systems. And they also, early on in their work, realized that one of their main problems from a nutrient loading perspective was point source inputs. So the point source inputs were wastewater treatment plants associated with the greater Brisbane area. There are a number of these plants that were identified as being sources. They used some very interesting and innovative tools to actually figure out how much of the nutrient, particularly the nitrogen, was getting into the various aquatic plants within Moreton Bay by using stable isotope tracing technologies. And the stable isotope tracing technologies allowed them to basically look at the condition before the upgrades to the plant. They then invested about $400 million in upgrading a variety of these plants. And then as these plants were upgraded, you can see a sequence as you go through 2001, 2005 to 2008. And you can see that the effluent point source inputs that could be traced with the N15 stable isotope nitrogen signal was largely removed from the system by a decade later. So basically removing some of that point source input to the bay. So some of the things that that this program, I think, did very well was the importance of getting the right message out and timing that message. And one of the things then that there was a very active communication program to convince the agricultural interests that reducing the loss of farmland and enhancing the functioning of these ecosystems and basically reducing channel and gully erosion was one of the important things that should be invested in. They also sold the idea that by reducing the sediment sources, there was going to be a significant cost savings in the amount of money that was spent on getting drinking water ready for the population there. It also reduced flood risk and damage, and it improved the overall health and, I think, viability of the waterways. And so they had some fairly dramatic examples. I was there during the latter part of the millennial drought in Australia. The millennial drought ended in the Brisbane area in 2008. And then they've actually had some fairly substantive floods, including this flood in 2013. And a lot of these restored watersheds did a whole lot better than the ones that had not been fully restored. So there is certainly a payback, a monetary payback that they could actually quantify from having healthy waterways and improved waterways in different parts of the catchment. And they also had a very effective ecosystem health monitoring program, their EHMP. This ecosystem health monitoring program basically was designed in a variety of stages. The first phase of it was a study that focused on the bay, and that was developed and implemented in 1998-99. There was then a development of a similar kind of monitoring program that focused on all the 15 major catchments. That was implemented in 2001, 2002. The design of that program is in this diagram here. It's basically an integrated evaluation program that utilized 5 compartments. The 5 compartments are a fish community analysis, an invertebrate community, basically health indice, bioindicator measurements, nutrients and their nutrients effects on primary producers, ecosystem processes like rates of primary production, rates of nutrient uptake, and then some physical and chemical measurements of the system. Each one of those sides of the pentagram actually produced a series of measurements. Those measurements were then scored. Each of those 5 areas received a 20-point score, range 0 to 20. And then the information on this was reported out in a very effective communication campaign that I had actually an opportunity to attend. And this is their report cards that they issue annually. The report cards are given out at various locations around the overall basin. The one I attended, there were probably about the same number of people as there is in this room, 100, 150 people. A substantive number of press, a substantive number of local government representatives, and then also a lot of the people involved in actually the monitoring program. It was a big deal. That big deal basically allowed the people there to hear how their catchment was doing, and it also in many cases allowed them to help get the resources necessary to do the improvements, to try to improve the score if their score wasn't up to snuff with some of the other systems. This program is also underpinned very much by an adaptive management program that has now been active and going for almost 2 decades. That adaptive management program has gone full circle. So it has gone through all the planning and all the other, the implementation, the analysis, the evaluation, the communication, the decision making, and then the modification. And I found it interesting that when Stuart was here, he actually used this figure. This is an overlay of how they were doing adaptive management in Australia, laid over the adaptive management plan or the adaptive management diagram that's in the Delta plan for the Delta Stewardship Council. So they took some of the ideas that we've developed and actually made examples of very concrete things that they've done in Australia associated with this Healthy Waterway Partnership. And the last thing I just wanted to say is that they have, I think, one of the most effective communication programs that I've ever seen linked to this evaluation and monitoring program. It is targeting all levels of the population. There are things for kids, there are things for high school students, there are things for adult continuing education, there's a series of study guides, and of course there's this report card that they report out on. And so here's a place where I think adaptive management has worked, and I think it's been around long enough that it's been shown its value and its efficacy, and it's a nice international example of some of the things we're talking about here. And I'll stop there, and I guess we can start the panel, or if you want to ask a question. The program it has 120 locations that are sampled twice a year, and the samples are collected for a variety of parameters. Each one of those 5 areas has at least 5 metrics that they are measuring within the system, and then they use the measurements themselves to score. So it ranges from 0, poor quality, to 4, good quality, and then that is how the information then gets summed up into the overall grade that the site gets. Is that what you're asking about? Yeah, they basically have criteria that are written up for each one of these metrics. So, for example, if it would be a sediment, a suspended sediment level, they would have a threshold that would be 0, a threshold that would be 1, a threshold that would be 2, a threshold that would be 3, a threshold that would be 4. So each one of the metrics has a range that sets the score.
Are those thresholds based on relating it to some kind of ecological function or a reference site or some regulatory derived metric?
A little bit of both. They have in some parts of the catchment things that they consider to be reference-like, and so they, in some cases, will use a reference. In some cases, they also have long enough term data that they can actually look to a baseline. So they use a bit of both a reference condition and baseline conditions.
Let's have some questions as the other panelists move up to the panel.
Steve.
Steve Culberson, the U.S. Fish and Wildlife Service. It seems like there could be a very strong role for citizen science in this, and maybe this is a question you want to take to the panel about some of their experiences as well. Could you speak to any role that citizen science plays in Australia?
Fairly substantive in that they often, that the sites that they utilize, these 120 sites where they're doing the measurements and making the determinations to give the grades, also then get adopted by school systems, and then actually they use these systems for actually getting kids out into the outdoors and actually in some cases actually involved in some of the monitoring programs.